Okay, in this video we're going to do the first part of section 3.7, which is 2.7 in the 6th edition. And we're going to talk about some special kinds of functions called one-to-one functions. So to start with, I have two functions here, f and g, and what I want is to find f composed with g and g composed with f. And what we found in the last video is that composition is not commutative, so we have to do it both ways. Okay, so f composed with g, remember, is the same as f of g of x. So I'm going to take g of x and plug it into f, right? So my f has 2 times x, so instead of x, I'll put in 2 minus 3 over, x minus 3 over 2 plus 3. Alright, so when I start simplifying this, I could cancel those 2, so I am left with x minus 3 plus 3, and the 3's cancel, and I'm left with x. Okay, now let's look at g composed with f. Now I'm going to take f and plug it into g, right? So I'll have 2x plus 3 in place of my x here, minus 3 over 2. There's where my f is, plugged into my g equation. So now I have 2x plus 3 minus 3, so the 3's will cancel. So I have 2x over 2, and the 2's will cancel, and I'm left with x. So this is what makes this a special function. First of all, it works either way, right? We get the same answer. And you notice what that answer is. It's like whatever I put in to the first one is what I get out after I do the second one. Okay, so suppose I do, oh dear, sorry about that. F composed with g of 2. Well, what that would mean is I plug 2 into my g equation, right? So that would be, I'd be looking for g of 2, so g of 2 would be 2 minus 3 over 2, so that would be negative 1/2. And then I plug that into my f equation, so that would be 2 negative 1/2 plus 3, and that would be negative 1 plus 3 equals 2. Alright, so you see that what I started with here is what I end up with after I put it through the composition. So when two functions have this relationship where they kind of undo the other one, we call them inverse functions. But what we want to look at is what kind of a function would have an inverse function. So here's just a really basic function, right? So here's our domain and here's our range. So in order for us to do an inverse function, it would have to undo everything, right? So since 1 is mapped to 5, when I put 5 in, I'd have to get a 1 back out, right? Since 2 is mapped to 6, when I put 6 in to my inverse function, I'd have to get a 2 back out, and so on. So here's what it would look like, and you notice that it's just flipped, right? So the domain, we have this ordered pair 1, 5, and that means in the inverse function we would have 5, 1. Okay, now, but look what happens here. So this is perfectly fine as a function, that 3 goes to 7 and 4 also goes to 7. But look what happens when we do the inverse and we try to switch that around. 7 is going to two different things. The only way for me to get a 3 out is when I put 3 in and I get 7. That means when I put 7 in, I'd have to get out a 3. And I do, but sometimes I get a 4. And so this is not a function. So not every function has an inverse function. Okay? All right, well, here's a graph of a function. And remember how we can tell if it's a function or not is by that vertical line test, right? So this makes a perfectly good function. Everywhere, when I look at x, there's only one y. So it crosses that vertical line only one time. So let's look at what it would look like if we were to do the inverse function, right? So this point right here is the point 8, 7. So on my inverse function, I would have to have the point 7, 8, which I think is right up there. Could move up just a hair. Yeah. This point right here is the point 4, 6. So I would have to have 6, 4 on my inverse function. Right? So each one of these things, this whole graph is just flipped, the x and the y. This is a 1, 2. I would have to have 2, 1 on my inverse function. And so on. 0, 0 would be just 0, 0. But negative 1, 0 would be 0, negative 1. And so on. And what it turns out to be is that if you see this line where y equals x, it's just a reflection over that. You see, every point is going to be reflected. So where x is, then y would be, right? So this is what the inverse would look like. But there's a problem because the inverse is not a function. All right, so but since we know we're flipping it, we could have told, yeah, so here we have this where in some of these x's there's more than one y, but in our previous one that means that on some of these y's there was more than one x. So this function, I can tell whether this function is going to have an inverse by the horizontal line test, right? So not even looking at the inverse, I don't even want to look at it. I can tell by using a horizontal line test whether or not this function is a one-to-one function. And it's not, right? Because right here where y is 3, I can get that in 5 different places. And that means that when I had the reflection, when x is 3, I get that in 5 different, it comes to 5 different y's, right? So that would make it not a function. So my original function was not one-to-one. So it doesn't have an inverse function. All right, so let's look at this one. This is our x cubed function, which is one of our library of functions. And so if you notice, this function, if we do the horizontal line test, it passes, right? There's no place where there's more than one place where that horizontal line crosses. Okay, so this is a one-to-one function, and so we should be able to find its inverse. And again, it's that flipped over, we can draw it by just flipping it over the line y equals x, right? And this is this is a function, passes the vertical line test because our original function passed the horizontal line test, and you might notice that you should recognize that function. It's another one of our functions in our library of functions. It's the cubed root function, and that means that they are inverses. So we'll look just at one more example where I can change this around. So this is a function. You notice that it passes the vertical line test. Does it pass the horizontal line test? No, because it crosses in those two places right there. Now, I could make it even closer, right? But if there's even one little place, doesn't matter, if there's just one point where it doesn't meet that horizontal line test, then it's not one-to-one. Okay? So here, let's try this. This would be now a one-to-one function, and because it passes that horizontal line test. And could you sketch the inverse function? Yes, you could, because you could, it actually overlaps, it looks on itself a bit, but you could draw the reflection over that line, and it would be a function. So, our parabola, our square function that we use it so often, and look, it's not one-to-one. So, does that mean we're not going to talk about it? No, it doesn't. See, we can make it one-to-one by restricting the domain. So, if I define this square function as I'm just going to use the positive half, right? So right here in the middle, where it's symmetrical around that point, right? This side is the same as this side. If I just use the right side, then it will be a one-to-one function, right? So you can see that it may be defined for the whole thing, but if I define the function and say that I'm going to use this function x squared, but only with the domain where x is greater than or equal to 0, then I have an inverse function. That makes it one-to-one. And what's my inverse function going to be? It's going to be the square root function. Now, I have moved these. These aren't exactly the square function. It's shifted up one, right? And this isn't exactly the square root function. It's shifted over one. But these are inverses of each other. You see that there's my line of reflection, right? So there are times when I can take a function that's not one-to-one, and I can restrict the domain so that I'm just using the part that would make it one-to-one. Now here's your quiz question for 3.7a, or 2.7 if you're in the 6th edition. Is the greatest integer function, which is from the library of functions, that's the one that we did in class, it wasn't on the video, but it is in the book and we did it in class, is that function a one-to-one function? Write your answer in Canvas in the quiz.